Hello, my name is Mark Pimentel. I'm a CAM application specialist here at Hawkridge Systems, and in this video I'll be showing you how to create a custom milling tool. So by custom milling tool, we're referring to a shape of a tool that is not found in the standard CAMWorks or SolidWorks CAM library. So this could be just a simple flat end mill where you want to change the overall profile, maybe give it a reduced neck with a taper or a fillet, or this could be a full-on form tool that you are defining the exact shape and profile of it. And you could do that either creating it yourself inside SolidWorks or importing a sketch file from a third party. That could be your tooling supplier, or that could be a customer's defined form tool. So in this video, I'm going to be showing you how to take something like this, which I got from a supplier's website, and it's just a simple DXF file of the overall tool shape. And you can see that it has a lot of features on there representing the insert, maybe even some inside areas there. Really, I'm not going to use all of this. I just want to get that outside profile. So what that means is I need to translate this into a SolidWorks model. So I'm just going to take this off screen here for a second. And I'm going to show you how I translated that into a SolidWorks sketch model. So this could be done just using the simple file open and then open up the DXF. Your SolidWorks will ask you if you want to create this as a DWG file or translate it to sketch geometry. If you ask it to translate it to sketch geometry, you get a file like this. Now this itself is not useful. I need to do some trimming. I need to kind of modify this a little bit. I'm going to show you what that looks like in this next window. So I've actually made a solid off that, but let me show you the sketch that I used to create that. And it's the same file we were just looking at. I trimmed out the inside bits. I've actually given it just a center axis because we are going to turn this into that revolved solid you saw a second ago. And you can see that I've trimmed out the bit that represents the insert. Really, CAMWorks and SolidWorks CAM are looking for just one solid. You want to define your tool as this one overall solid. I've actually just kind of trimmed the inside bit so I get these nice lines here. This will revolve into a part that looks like my actual tool. So it's from here where CAMWorks will pick up and turn this into a custom milling tool. So what we'll do is we'll go to our CAMWorks tab and we'll go to the left side here. Now if you have a larger screen than mine, you probably don't have to click on that icon, but if you don't, you'll click on those double arrows and you'll go to user defined tool. And you can see that it takes that solid and it generates that shape right there. Now the reason this is possible is because I took that translated DXF file, I took that sketch geometry, moved it to the origin of the sketch, rotated it 90 degrees so that it is oriented this way. So you have that y-axis as your rotary axis, and you've got the sketch oriented in the positive x and y plane. So that's actually important for the sketch. It needs to be centered on the origin, and it needs to be in the positive x and the positive y direction. So once you've got that and you do a revolve solid, you can turn it into this shape definition here. If we go to file type, you can see that you can actually use these shapes to define either a custom milling tool, a custom mill holder, or a turn insert. And we'll be covering turn insert in a later video. But in this case, this methodology will cover custom milling tools and custom holders. From here, you take this shape definition and you just save it. Save it wherever you like. I'm just happening to save it in the folder I'm using for this video, and I just called it front back chamfer mill. So you would just choose your folder location and click the green check mark. Now that I have that shape definition, I'll go back to my top right corner here and I'll go to my technology database. On the left side, I'll go to mill tooling. And in the shape tool definition over here, I'm going to scroll down and find user defined tools. So again, if you have a tool that you're looking to define that matches any one of the other shapes, I would say try using those first. Modify the parameters, modify the dimensions in these categories, and you'll get close to what you're looking for. But if you can't find anything that matches there, we'll go to user defined tools. You can see I already have my double chamfer tool already defined, and I just populated this information here with the information from that DXF, the catalog dimensional information. One thing to note is you actually don't see a new button anywhere over here. That's because the library, it has preloaded tools, and it's usually a good idea to just copy one of those tools and modify what's different. So whatever shape tool I have on this list here, I would just click on the first one, click on copy, and in that copy, I would modify what's different. So I would go in here and I could just change it to whatever I like and then just match all these parameters to my custom tool. What makes this different from whatever file I just copied is when you scroll down to the bottom here, you can see where it says tool name and path. This is a link to that shape. You can see here that these are a bunch of shape definitions that come with the software for all of those unique shapes. You'll actually find a few of these for the standard shape sizes as well. I would say don't change those, but if you're looking to make your own shape tool, all you have to do is just browse to where you keep that tool. So in this case, I would just browse to my .mt file that I created a second ago, and you'll see that in this list, I've got that already linked down here. So I put in all the dimensions of my double chamfer tool. I've linked it to that shape. I'm good. I can get out of here. And now that tool exists. If I want to use that tool, well, it's simple enough. I'll just show you a file where I'm using that tool. I'm looking to do the underside chamfer here. I'm just kind of deburring that edge there. And I have a simple contour mill operation where I'm using that tool. So we go to Tool, Tool Crib. You can see that I have the tool selected, and you can see that it comes in with the shape that we defined. So you select the shape tool the same way you would choose every other standard tool. The only difference between using this tool and other tools is it is a shape tool. So you want to make sure you know the shape of your tool, and you want to add appropriate allowances on the side parameters and the depth parameters, because when you define a tool, it actually is defined by, if I just go back to my tool section here. The tool is actually defined by its cutting diameter and where the tip of the tool is. So the tip is actually defined as being that bottom center, and then that cutting diameter pretty much makes an imaginary point right there. So if I were to do my contour mill, it's going to follow the point where my mouse is right now. So I just need to know the shape of my tool, which again I have because I have the catalog information, and I know how much to drop it in the Z direction and how much to shift it over in the radial direction to get a toolpath that does exactly what I'm looking for. And if we just take a look at that in a step through, we can see that with the dimensions that I plugged in, I'm getting it right on the edge there, right before the fillet basically of my insert. Now, one quick little thing I would say to help with that idea of the shifting is there's no real guesswork there. All you got to do is just go back to your tool definition, and you can create a sketch like I've done here, or I just take the dimensions right off there. So using these dimensions, I know from the tip here, for instance, this tool is unique in this manner, but because the radius is making the cutting diameter smaller than this actual mathematical point here, I just take all these dimensions into account and then define them as my allowances. And then that gives me my exact movement of the tool based off the shape of the tool. So creating a custom tool inside CAMWorks is pretty simple. You just need a 3D model based off a sketch that you've created yourself, or you translated from a catalog information or from a supplier's information, and then using that shape tool or that form tool in your operations is the same as every other tool. You would select it from your tool crib. The only difference here is you need to know the shape of your tool to better modify its movements, and that is where SolidWorks can come in with these sort of sketches and these dimensions here to help you understand a little bit better the shape and the movement of your tool. Any questions on this, just give us a call at the main tech line. If you like these videos, like and subscribe to our YouTube channel. Thanks for watching.